It's time for some jumpy, jumpy, jumpy. All right, to get our jump set up, we're gonna open up our player movement script, and we're gonna add two variables here. The first one, specifically, we want our jump speed, right, to keep track of our speed in the Y direction going up and down. And we're also going to need a variable to increase when the character jumps and decrease it over time according to the gravity. So that one we're just going to call our Y speed. And we actually don't need to serialize this one. We can just make it private. And we'll go into our update underneath our move player method here. And here we're going to go ahead and set our Y speed. And we're doing the plus equals, so that's going to assign the Y speed and also add to it. And we are adding to it the physics.gravity.y, right? The gravity of Y going up and down. And we also want to make sure this is times our time.delta time. So that way it's per second. So the default gravity value is negative 9.81 in the Y direction. So this will decrease our Y speed by 9.8 every second. Okay, this is going to decrease our Y speed. So now underneath that, we'll write an if statement for our input. And we want to check if the jump button has been pressed, and then now we want to set the Y speed to our jump speed. So we're simply just going to say when you press the jump key, the Y speed will be the same as our jump speed. Now let's find our character controller dot simple move, and this method, then we've got our speed, movement, direction, and magnitude. And what we're going to do is select all of these in the parentheses, and we're going to go over to this light bulb and click the drop down arrow, and we're going to do introduce local for these, and we're just going to call this now velocity. So basically we're assigning the speed, movement, direction, and magnitude to this variable velocity. And then velocity we're assigning to our simple move. Right underneath that, we're going to take our Y velocity. So we'll just do velocity.y. And we're going to assign that the Y speed. And we briefly mentioned before the simple move that the character controller has two methods we can pull from. So instead of using the simple move, which is nice and simplistic to get you going, we're going to just use just the move method. It's a little bit more complex, but not so much for us. It's going to work great. Now, with move, we're going to need to make sure we use the time.delta time with our velocity, so we're timesing that. Right, again, this is going to ensure the player moves at the same speed regardless of the frame rate, right, the FPS. Save that, Control S, and then switch over to Unity. And before we play test, we want to select our player, go to our player movement script. We got speed of 5, 720 rotation, and then the jump speed, we're going to go ahead and set to 5 as well. You'll notice when we fall off the wall, it plops down. So if we select our player again, and then we go to our inspector, there's 3 dots for our inspector settings, more options. We're going to click that. We're actually going to do the inspector in debug mode, which will actually show us our variables that we don't normally see. So we go into debug mode, and we get those. Now what we're looking for is our player movement script. We're looking at the Y speed here. So jump around again, and when we fall off, you'll see our Y speed there is continuing decreasing. This is why our player falls so fast. So we need to fix that so that the player won't just like plop off and fall really fast. What we want to do is set the player to only jump while on the ground and only accelerate under gravity if it's not on the ground. So when we jump up, then we want it to accelerate for the player to fall down. So what we're going to do is underneath our, if we get the input jump button, above this, we're going to start with an if statement. And we want to get our character controller. And our character controller has an is grounded Boolean that we can use for this. The character controller has that built in. So we can just say character controller or controller dot is grounded, since that's already set up for us. So if the character is grounded, then we want to be able to jump. So I'm going to cut this, Control X and Control V to paste it. Now our player will only jump when we're on the ground, but we want to set our Y speed back to 0 when we're on the ground. So above the if statement here, we can simply say, hey, if we're grounded, then set the Y speed to 0. And if we're jumping, then the Y speed becomes the jump speed. Now our player will fall properly. So right here, we want to fix this with adding some coyote time jumping off the platform, as well as a jump bumper for being able to hop around or jump multiple times on the ground floor. All right, we're going to need a few more variables to make this jump feel right. So we have our jump speed, and we also need a float for the jump button grace period. And we need a variable to store the time the character is on the ground and to store the time when we pressed the jump button. So what we're going to do also is we're going to add in 2 more private variables. Now, here the deal is, though, we're going to do something a little bit different. We want to do a float question mark last grounded time and a float question mark for now the question mark means that it is nullable. We can make it null so that the value has either no value or it's a float value, one or the other. Initially, we want to set it up to have no value, and then we want to clear it out when the player jumps. All right, so we're going to go down to our update and add in another if statement. And here we're going to check to see if right controller is grounded. And I'm going to duplicate that as well. Here we want to get our last grounded time. And we're going to assign that the time.time. And this is going to be the number of seconds since the game started. Then after that, we also want to be able to get the jump button time. So I'm going to copy get the input here. So we're going to do if we received input for the jump button, then we want to get the jump button press time. So this is the jump button has been pressed, and this will give it the time since it's been pressed. So here, instead of checking if is grounded, we want to check if the player is on the ground within the grace period. That'll give us that coyote time where we thought we pressed the button and we expected to jump off the platform, and instead the character falls. We want the character not to fall but to actually jump still. So we're giving the player a little leeway. So instead of is grounded, we're going to write time.time, and we want to minus the last grounded time, and this gets the amount of time that has passed since being on the ground. Now we need to check to see if it's less than or equal to the grace period. So we'll add in less than or equal to jump button grace period. Alright, I had a glitch earlier, but instead of doing the y speed at 0f, we can just set this to negative 0.5f just in case. And then next we want to get the amount of time that the jump button has been pressed. We want to check if that's less or equal to the grace period as well, not just the jump button. So what we can do is go ahead and change this. Instead of the input here, we're going to do time.time minus the jump button pressed, and then see if that's less than or equal to the jump button grace period. So that way we're checking is the amount of time that we passed since being on the ground and the amount of time that we pressed the jump button. So next, save this, and you could play test it out to see. Next, what we want to do is when we do jump, we want to make sure that we reset the jump button press time and the last grounded time to null, to nothing. So we'll put those in here. Save this, and we'll go back into Unity and set our settings. So we'll go into our player movement script, and we could go ahead and turn off debug mode back to normal mode. And we have our jump speed of 7, and for our jump button grace period we can do 0.2. That gives us just a little bit more time from coming off the platform to be able to press the jump button. There we go. Alright, instead of configuring this jump with a jump speed, we're going to reconfigure this for our desired jump height. How high do we want to jump? So we'll get back into our script, and at the top here, instead of jump speed, we're going to change this variable to height. Now, we also want another variable because we're going to alter the gravity for our player when we're jumping or falling, so that way we can make it feel less floaty. So I'll put another variable here, float, and we'll call it gravity multiplier. There you go, save that. Alright, so we're going to scroll down for our Y speed, where we have our code for the gravity acceleration to the Y speed. Now, we're currently using the physics gravity value to accelerate the Y direction every frame. What we can do is add a line above to calculate the gravity, with applying the gravity multiplier. So just right above that, we'll add that in. Then here we can just change this line and put our variable there. So our y speed is we're going to be adding to our y speed our gravity times our time.delta time for putting it in seconds. We're going to need to know when we're jumping. So underneath our private other jump variables, we're going to create another one for our private Boolean is jumping. We'll use that Boolean as a true or false statement to know when we're jumping. So we'll come down here, and this is checking for our jump button grace period. We've got our y speed, and what we want to do is say that is jumping here is equal to false. And then if our time minus the jump button press time is less than our jump button grace period, then we can jump. So in this case, after our y speed, we're going to set our is jumping equal to true. And then we no longer have the jump speed, we actually have the jump type instead. So what we're going to do is we're going to use a math formula. So we'll just delete this and type in math f, or a math function. And the math function that we're going to use is sqrt, which is going to return the square root of parentheses. And here what we want to do is get our jump height variable. We're going to times that by -3 for right now, and times that by the gravity variable, and save our progress. And then we'll go back into Unity, and we'll want to set that. So for now, our jump height, we could set that to 2 for now, and our gravity multiplier 1.5. So let's scroll up where we have our gravity and y speed. So what we want to do is we're going to put an if statement here. And we want to say if we're jumping, and also the y speed has to be greater than 0, and we also have to have input get button jump. The input button has to be equal to false, so we're not pressing the button. We want to make sure we're jumping in an upward direction, so we only slow down when falling from the jump. So if all conditions are met, then we're going to take our gravity and we're going to double it. So we could write out, gravity is going to be assigned, right, gravity times 2. But there's a faster way of doing that, because this is going to take our gravity times 2 and reassign it back to gravity. So instead, we can just shorten that input times equals, and that will double our gravity. Now, in order for this to work right, we need to have our code in the right order. So I'm going to cut out this y speed factor, Control X, and paste it underneath. So this will make sure that if we want to do a low jump, it'll do a low jump and do 2 times the gravity, or it'll be a high jump, and we can play test that out. Make sure you save your script first. Now if we just tap the space bar, we get a little tiny jump. And if we hold down the space bar, we get a really high jump. High jump, little jump. High jump, little jump. So, there we go. I did notice a glitch here. If I jump up, you notice there's a visual glitch where it's the step offset is wanting to step up. So let's fix that. So to make sense of this, the first thing that we want is we want our step offset to be 0.2 when we're on the ground. But when we jump, we want our step offset to equal 0. That way, it's not trying to glitch on the wall or think like, oh, is this some sort of checking the step? And it kind of does that glitch whenever it is on the side of the pillar, which if we had a taller wall, it would probably do the same thing in some cases. Open up your player movement script, and underneath our private bool is jumping, we're going to add a private float for our original offset. That's the step offset. So we could call it step offset as well. Original step offset. Either way is fine. And then if we come down to the start of our game, when we start the game, we want our original step offset. We're going to get and assign our character controller step offset value. So in Unity, our character controller has the step offset right here set at 0.3. So I'm actually going to set that to 0.2. And so here we just have to say our controller dot step offset. So at the start of our game, our original step offset, it's storing that to be 0.2. Then we'll go down to line 49 here, where we're checking the time minus our last grounded time, and if that is less than our jump button grace period. And before our Y speed, we're going to get the controller step offset, and we're going to assign it the original step offset value, because in our if statement, if we're jumping in the air, if jumping is true, then we want our controller dot step offset to equal 0. So that way when we're in the air, it is 0. But if we're not jumping, then it puts it back to the original value, which is whatever we are going to have set in our inspector. So we can save that. And then make sure you save your project and test it out. And I'm also going to reduce the jump height, maybe 1.8 for right now until I change the walls. So since the walls are a little bit short, the player can jump up on top of those, and maybe I don't want that right now, so I can kind of reduce my jump height as well. Here is the result of that code real quickly, the 4 lines that we added in for the step offset.